welcome. So this is one of our deep dives. And in deep dives, we choose a theme or subject, and we basically dive into try and teach you guys as much as we can about that specific topic. And today we're talking about rules. So basically, a bit of the agenda. I'm going to do a quick intro to Flux for whoever's not fully aware or just happened to see the event and joined. And then we're going to be diving into what rules are. So basically, what's a DRC for whoever's not aware, and then how Flux works differently from that. It's going to take around 30 to 40 minutes. We're going to do a live demo of some of the rules to show you guys how that works. And before I get into that, so if anybody has any rules that you'd like to cover, any specific one that you either don't understand how it works or you find interesting, feel free to type in the chat or even ask live. And I'm going to make sure to talk about that one when the demo comes. And then we're going to have a bunch of time for Q&A. And after that, this is optional. We're going to stay for about half an hour extra just to hang out and help anybody with projects, questions, or anything that we can. All right, so we're going to just do this quickly. I assume that most of the people here know what Flux is, but just a refresher. So Flux is a browser-based EDA or electronics design tool. We started this basically 2 years ago, and we've been making steady progress and releasing more and more tools and features. So what does it enable? So it's an integrated workflow. It means that you have PCB, so schematics, simulation, and PCB or layout built in the same tool, so no need to go jumping around different tools. So it's built around collaboration, people sharing designs, using parts that other parts of the community made, and it includes version control from the get-go. So there's no more sharing files with names called v1, v2, v3, etc. And then reusable blocks, which means, that people from the community can build blocks that somebody else uses on their design. So we build this collaborative approach. So a few key differences that are present rule in Flux. So nesting, which means that any part can be a module. So basically, when you double click on a part, you can see that it has multiple parts, and then you double click on any part and it has multiple parts in them. So there's no concept of a part is one component. So a part can be a sum of components that have one specific goal. We have a kind of a different approach to rules, or a few things that we do differently. And I'm going to stop here because we're going to talk exactly about that today. And the simulator that is built in the tool and it's always on. So there's no need to create files that you're going to then load into other simulation tools and then back and forth. Right. So jumping into the session for today. So what are we going to learn? So first, how rules in Flux are different than standard DRCs. How our approach actually makes designs better or makes a better way of designing, and how can you guys apply this in your projects? So basically, examples of different rules and how they can be applied in a sample project in Flux. All right, so a bit about me. So I'm Nicolas, everybody calls me Nico. I'm an electronics engineer, and I'm a product evangelist at Flux, recently joined. I mostly work in the IoT industry, so for a bunch of years, building from street cameras to action sport devices to carrier boards for industry, so on and so forth. And basically, in the past 4 years, I've worked in a remote environment, a fully remote company with a team of electronic engineers. And let's say that the experience wasn't great, and that kind of pushed me to join Flux. I was kind of looking for something that would allow a group of remote EEs to work seamlessly and not have to share files and do weird things. All right, so let's talk about rules a little bit. So just as a background, so DRC, or design rule checks, or design rule checkers, probably everybody knows about this, but just to set the stage. So basically usually how a PCB design works is when you're done with the schematic and you're trying to do your layout, you basically set up a bunch of rules that sort of set the structure of what your PCB is going to be like. For example, what the minimum trace width is going to be, separation between components, or how your polygons are going to connect to traces or not, and so on and so forth. You then do the design, and then at the end, you run checks for those rules that you just said at the beginning, which is kind of weird if you think about it, in many cases, right? Like if the tool already knows, why wait till the end? There's some tools that call the real-time DRCs, which is kind of real-time feedback that you're still doing something wrong. So it still won't prevent you from doing it, but at least it will tell you in real time that there's something wrong, and no wait till the end of your design. So our approach is, why not try to prevent errors in the first place, right? Like why not, like even sort of not have the designer do these errors that the tool already knows that you don't want to do. Some of them you cannot get away with, but some of them you actually can. So rules in Flux get enforced right away. There's no need to wait till nothing happens. We're going to talk about that in the demo, but just for you guys to have these two concepts in mind. So that is the first one. And then if you think about it, regularly when you talk about rules, you kind of declaring an intention, right? You declare that you don't want something to happen, or you want something to happen. But rules don't modify the design directly, right? You're not saying, okay, I'm applying a rule that sets this, and then that sets it, is set automatically. It's kind of an intention. It's like, I want this to happen. And if you as a designer don't make that happen, the tool will tell you that you didn't. Again, all this is going to make a lot more sense with the demo, but just have to have this in mind. Of course, DRCs still have its place. I mean, there's some situations where they're useful and they need to be. And DRCs, I mean, in this concept of I define them, I decided that at the end, they tell me if something is correct or not. So for example, errated nets, right? While you're designing, that the tool cannot know when you're done or when you're not done. So if you have an errated net, it will be useful to know. So if you run a design rule check and you miss the net, the rule can tell you, hey, there's a net. Or broken planes. I mean, there's a few examples where DRC still makes sense, and this is a roadmap for Flux to actually implement. Okay, so how rules work in Flux, and there's basically three concepts that we need to sort of wrap our heads around. So first, what actually is a rule? So it's basically a property that you define for an object. So it could be a footprint or a component, a pad, a via, a hole, or anything like that, right? So here's a bunch of examples of what some rules are. For example, the units that component is going to use, or what position is that component, or how much you want to rotate that component, and so on and so forth. Again, we're going to go through some of this in the demo. And then what we call the rule selector, which is basically, you can think of it as a query that will tell you which components will that rule apply to. right? So let's say that I create my selector, which defines a selects a bunch of components. For example, this pad or that component or that via that, for example, is connected to a net or has a specific property or whatever that may be. So it basically allows you to select specific components based on a different number of options. Just for reference, so our query syntax is inspired on the CSS selector syntax. So for those who are familiar with that, it will feel super natural. For those who are not, it's not really complex. It's just a syntax. Here's an example of a rule selector. So basically, this selector will match every object that has a designator that starts with stm_pa. So just to start getting aware of what the syntax looks like. And then what we call rules specificity. So basically, you can have rules in different levels, and one rule, so that the rule on the top level overrides the rule on the bottom level overrides the rule that is on top, right? So the most global rule is our system defaults, right? And then from there, the next down. So if you have a rule that is inherited by a component from its parent component, again, we're going to talk about that later. The inherited rule takes precedence over the system default. If you create a selector rule, that will take precedence over the previous two. And if you add a rule for a specific object, that will be basically the one that takes precedence over anything else. That's just to keep in mind, how can you make this cascade, and when a rule applies and when a rule will be overridden by another rule. All right, so let's see a few examples. All right, so let's create a blank project. New blank project. Okay, so this is basically the standard. I'm gonna move all the videos away. Okay. All right, so let's start by dragging a few components here. So to resistors, let's put a ground symbol. And a terminal or a pad. Let's do this. All right. Now let's go to the PCB. Okay, this is what we've got. Let's just make a quick write a few things. All right, I went through this very quickly. Assuming everybody knows at least the basics of how Flux works. We're also going to add a link to our chat later of our previous crash courses. So if you guys are not familiar and you want to sort of a deeper dive into how to make stuff in Flux, you can watch some of our previous crash courses. But just to basically do a very, very brief overview, so not to lose anybody. So what we did on the schematic was I searched the library for a few parts. So I searched for two resistors 005, I place a ground symbol and a terminal, which we can consider for the sake of this presentation as a pad that is connected to a specific net. So what I did when I searched, I just made sure that all the parts that I use, and these, by the way, are all parts from the community, right? Like I haven't created any of these parts. So if you've seen, so if you see who created the parts, none of them is me. So this is one of the magics of Flux. You can reuse other people's work. The only thing that I made sure is that it has this symbol, which means that the part actually has a footprint, right? So that I can use it on my PCB. All right, so let's take this very simple simple design, right? So if you go to rules, this is sample. So if you go to the rules menu, I'm going to have the possibility to create new rules. So let's put this trace width. Okay, I can have a description for rule sets trace with boundaries. So basically, here is the selector that I was just talking before. So this allows me to match for specific components. So what I can do here is I can batch for trace, right? And this will match all the traces in my design. So you can see it says selected 6 objects. So that basically is telling me that I've matched all the traces in my design. And then I can go to the layer rules and start adding rules. So as you can see, there's a lot of rules. Some rules make sense for some specific elements. Some rules do not make sense. So we actually released this week this dialogue when you add a rule, so that it actually explains you what that rule means. And some of them even have some illustrations to basically explain a little bit better what the rule is all about. I'm gonna go over this one specifically later to show you the illustration. But for now, let's start with, we can add a minimum trace width and a maximum trace width, right? Done. Okay. So as you can see here, this one is already kind of pre-populated because it's one of the system defaults that I talked about before, right? So I can definitely override this, and this is one of the things that that you can start seeing the difference in Flux. So for example, if I change this to 0.2 millimeters, you can see that you'll see that the trace starts growing, right? If I put 1 millimeter, immediately the trace gets bigger, right? It doesn't wait for me to do something and then tell me that what I was doing was wrong. I will just automatically update that, right? I can disable the rule or enable the rule, and the same thing, I can enable or disable the global rule, right? So each rule can have multiple rules applied to it. It's kind of, terminology is a bit confusing, but you can see this as the definition of the rule, and the rule can define different properties. In this case, also called rules, different rules in the same one, right? But all of them are going to be applied to the options that I selected in the selector. And here I can put 2 millimeters. And then basically when I try to create a trace, so let's now go to this trace in specific and see what we have here. So this is what I was talking about before, right? So you have all the system default rules with what they are, and then you can see that some are crossed, right? Because it is something that potentially gets overridden afterwards. And then we have the parent or inherited rules. And I'm going to stop a little bit to talk about this. Okay, so objects in Flux have a hierarchy. So you have basically the root, which is the whole layout, let's say, or the whole PCB editor. And then within that, you have a layout, which is this, which is actually the what's going to be the PCB. So if I go move the videos again, so I go here, you'll see that the board is as big as what the layout is, right? So what I was saying is that you have the root, and then the layout is a child of the root, because so the layout is contained within the root. And then basically you have components that are contained within the layout and nets that are contained within the layout, right? So if I apply a rule to the layout, all the components are going to inherit that rule if the rule is inheritable. Some rules are not inherited, but most of them are. So basically in this case, when I clicked on this net, it's telling me that it inherited some of the rules, right? And you can see the stack up, the layout shape, and all that you can kind of tell that they're coming from the layout, right? So the stack up is coming from the layout, layout shape is coming from the layout. So these are the rules that are inherited by this specific element. And back, and then you have the selector-based rule, which is the one that I just created. So we can go back to it. Is the one that I just created. And then finally, we have the object-specific rules, right? So we have all the staircase of hierarchy. So the system default, the inherited rules, selector-based rules, and then finally the object-specific. So I can, for example, add a trace width here, right? And I can put the trace width on whatever, 5 millimeters, and it will be fine. I can put 10 millimeters, right? And at that point, it won't grow. Oh, sorry. I can say put 1, which is the minimum. And then I can put 2. And then it won't stop, won't grow anymore, right? Because the maximum that I set is 2. If I disable this rule, the trace width is going to be 3, right? But if I enable it again, it will go back to 2. So what this means is that it won't let me go over the maximum. So if I want to actually get over the maximum, I will need to go and change this, right? Okay, so this is what I was talking about when I mentioned that rules get it's like an immediate effect, so they don't wait for something else to happen at the end of the design. So by the way, if there's any sort of super pressing questions, happy to answer. Now let's talk about the other concept, which is that rules not only set the stage or set the structure, but can directly affect elements or components or whatever that is. And we're going to start to see what the what the power of this is. So we have this part, right? This part is a see if I can find it. Oh, it's a path to the default. So the system default is that all path types are SMT, right? So now let's try to create a rule. Let's call it path shape. We're gonna, let's say, look for pad, and then I'm going to say pad type, which is, so as you can see here, it says it defines the type of pad. So SMD is a surface mount, hole is just a real hole with no copper, standard is basically a through hole pad, and then con, which is basically very similar to what where an SMD pad is. So let's add this, and we're gonna. So if we keep it at, with my pad. Okay, so as you can see, the rules, pad shape. Okay, so you, as it is now, it is an SMD pad, right? I can change it to make it a through hole pad, or just a hole, or the other, just a connector. So let's make it a standard pad, which is basically a through hole. So if we zoom in, we can see that you have a pad and then the hole in the middle, and then the trace is connected to it. Right. So that we can start understanding what the power of this is. So for example, so the design is exactly as it is, right? So I can, for example, go to the objects and then grab insert another pad, right? So in other tools, how would you probably do this, right? So if I wanted to make this pad a through hole instead of a standard, I would go in and edit this pad, right? But what happens if I add a new pad, right? This new pad, since I only edited this one in the other scenario, it would be, the new pad will be the default, which is an SMD pad. The power of rules is that they apply real time, the whole time. There's no case or moment in time where they do not apply, right? So if I go to the pad shape, like every pad that I add from now on, it will have this specific shape. Or I can say, okay, no, I want only the paths from R2, right, to have this this shape, right? Or another option is I can go back to schematic, and this one I'm gonna call it. I'm gonna change the designator. I'm gonna call it 5 volts. So then I go to the PCB. I go to my pad rule. And what I can do is I can say, okay, the pad that is called 5 volt is the only one that I want to be a through hole pad. And the powerful thing about this is that you can, in the same design, have different layouts, right? So you can say, okay, I have one product that where this pad is an SMD, but without having to change anything, I can go and then disable this rule, and then that pad instantly converts into SMD, right? So the power of rules is that you basically can modify big chunks of your design without having to create multiple variants or maintain multiple designs. Another case would be, for example, if I create a new rule, which is enable, and then I can select R2. And then I'm going to add a rule that's called enabled, and then I can turn it to false, right? So R2 suddenly disappears. So at this point, you're like, okay, I can create, again, variants of the design. And I can even go as far as to say, okay, I'm going to, for example, take one of the nets, this one on top. And then I'm going to rename it. And I'm going to call it our res, whatever. I named, you can see I renamed this net, just for context. So the net is the whole net. The trace is the segment of that net. So that I can go to the rule and say, okay, I not only want R2, but I also want res, right? So at this point, you're like, okay, I can make a whole chunk of this design disappear. And I'm going to talk about this ADB build later. But I wanted to, okay, let's remove this. I also wanted to talk about something that I think we can pretty much all relate to. And I think it's very powerful in Flux. So let's get a...
There's a couple of questions in the chat, Nico.
Let's do it. Okay.
Do you want me to read it out?
I got it. Okay. I'm going to read it out.
Answered mine, so.
Sorry, who was that?
I was just asking you, select multiple, like resistor 1 through resistor 5.
Yeah, you can select more than one thing. Exactly.
Now, are you able to, let's say, for example, you do resistor 1 through 5, but then you can be like, oh, not resistor 3. Is that also an option where you can do that?
Yeah. So there's a bunch of things that you can do. What you can potentially do is have designator, for example, and then match the ones that begin with R, for example, with R. See, and I selected everyone that started with R. Or I can do a full, which is 2. So I mean, so if you click on the help button when you're going to Flux, you can find the sort of all the things that you can select for. So you can select directly by the designator, or for a property. So for example, let's try the property one just to put another example. So let's grab this resistor. So let's say that this manufacturer is, I put the manufacturer on Samsung. So I set a property that is manufacturer name Samsung. So I can go to this resistor and say, okay, manufacturer name equals Samsung. And then I will select that and it will disappear. So there's a whole bunch of options on what you can do to select or not select rules.
Yeah, I like that a lot.
Yeah, exactly. One of the powerful things that you can add properties to it and then select based on those properties. So I add some properties to some elements and not, and then select based on that.
Okay. Cool.
So
Thank you.
No worries. Can I make a rule that makes footprints unchangeable? This rule change the footpaths. So basically, if I understand your question correctly, you want to make a rule that basically locks that component from being modified. Correct?
Yeah, because once you add rules that change the shape of the parts for a whole layout, it's change all footprints parts as well. So it's not what I want in this case. Of course, in some case, I want to modify footprints on this on the project. For example, if I need make part bigger to easily solder them, hand solder. When I try to not make a prototype which I will modify manually. So I need this path bigger, but in final product I will use the smaller. So what I asking right now is, can I lock the footprints paths, prevent them from modifying by mistake or something?
I don't think you can. I mean, you can create another rule that applies to that specific component and set the specific path shape, for example, if you're worried. But I don't.
Maybe some rule when I tell the Flux that if this path belongs to some components, you can change it. If it's free path, it's okay.
So you can create a rule that only affects free paths if you want, but but I don't know. I don't think there's a way to create a rule that basically locks a component from being able to modify it, to be modified. I'm gonna take notes of this and discuss it with the team and see if it's something that we want to implement, or if somebody else can think of a way of doing that. That is not basically creating another rule that only matches that component that you want to lock and then add all the rules for that component. So basically, if other rule wants to change it, it can't. So yeah, I'm gonna get back to you on that.
Okay. Thank you.
Yep, no worries. I think there's no more questions, right? Yeah. Okay. So let's move on. Okay, so what I wanted to share with you is something that I think many of us can relate to. So let's grab a microcontroller. Actually, Basil, I'm gonna grab yours. All right. Again, just typed on the library a microcontroller that I wanted to use as an example. I made sure that it had the footprint icon. I mean, I can also filter, right? If I click on here, I'm gonna filter only the ones that contain footprints, or the ones that contain footprint and contain sub modules, or the ones that I created, or whatever that is. So I can filter for a few things when I'm searching. Okay, so now that we have this IC, let me hide a few layers. Right, so what we're seeing now is the solder mask. So basically what happened to me many times, and specifically when you're dealing with microcontrollers, or some of them that have like a small pitches, is that the space that you have in between two solder masks, like this sliver, it's called, basically so here you're going to have solder mask and here you won't have solder mask. Many manufacturers, specifically the cheaper ones, cannot build, so since their solder mask is lower, so their process is lower accuracy. If the solder mask is too thin, it might peel off. So we can assume for this example that a specific manufacturer cannot do solder mask this thin, right? So what will be the common use case, or what happens usually, right? So these are some rules that, depending on the manufacturer, you set or not set. And many times you don't know exactly which manufacturer you're gonna use for your design, right? So at the end, you go and check the manufacturer and say, oh, like this manufacturer has this specific requirement for the sliver. So you go back to your design, you add your rules. Says, okay, the minimum width for solid mask sliver is going to be 0.1 millimeters or whatever. And then you're going to have, for example, for this component, a bunch of rule violations saying, you have all these slivers that are smaller than what you said they should be. And you have two options here. One option is that you go to the footprint that you used, you do something like this, for example. So I'm going to edit, I'm going to add a specific rule, solder mask expansion. Okay, here you have the explanation. So basically what it means is that you will expand the solder mask from the edge of the pad by a certain amount. So if the number you put is positive, it will expand from the edge, the amount that you set. If you put a negative number, it's going to basically contract from the edge that amount, right? So let's put 0.1. So this is basically what you're going to do in your footprint. So you're going to go, you can edit the footprint, and then you basically create a full mask so that your rule check doesn't fail. And basically, in some cases, what happens is that these things start to peel off, and they might start to take off the rest of the solder mask. Now, what happens is if you change the footprint, next time you want to use that footprint, it's going to be changed, right? So if the other manufacturer that you end up using, or you share this part and someone else is using it, another manufacturer that that has a better process and then can actually do this, you won't get the benefit because you change the footprint, right? The other option is that you only change this in your project. So basically what I did here. So I went in my project and then I changed this, this thing. The problem here is that when I do this, normally there's kind of no record that this happened or why this happened, right? So I went in, modified this, and then continued, and someone else might look at this and say, like, why did they do that? Or they might not even know that I did that. So it's a modification that kind of gets lost in the myriad of modifications that you do for your project, and that is kind of dangerous, right? So what happens in Flux? So let's delete this rule, and then what you can actually do in Flux is, for example, you can say, call it sliver, set solder mask to eliminate sliver. I can select U1, then I'm at the solder mask expansion, and then 0.15. So put the solder base, sorry. Solder mask expansion. 0.15. That is done. So basically, what happens is that in the future, if someone is going to review my project, they can go and take a look at all the rules that I've set, and they're like, oh, what is this lever? Oh, set solder mask. What this applies to? Oh, this one, this, and I can even tell to limit the lever for whatever JLC PCB process, right? So that is already a huge help. This can happen for margins. This can happen for shapes of paths or anything like that, right? It is very clear. It's like you're declaring, I made this modification and why I made this modification, right? But it doesn't even end here, right? So what other person can say is like, oh, but only my project is benefiting from this. So why? So if I'm the owner of the part, can I build this functionality in the part so that anybody that uses my part can benefit from it? And this is where collaboration actually starts to make a lot of sense, right? So you build your parts and you build in functionality on it so that other people can benefit from. I'm gonna talk about this one and finish for the question. So basically what I can do is, let's say that I'm the owner of the part, right? So in this case, I'm not, it's Basil, but they say that I'm Basil, and then I go into my part and I add a property to my part. So, and then I'm gonna call this property sliver remove. And then, so this unit is gonna be millimeters. Done. And then basically, so I know that to remove the sliver on my part, I need a 0.15 millimeter solder mask. So bear with me. So what I just did was, so in this case, I did it in the schematic for my project, which only will apply to my project. But if I was the owner of the part, or I can, like, another good thing about Flux is that I can open the part. And basically now I'm seeing what that part is. If I was the owner of this part, what I would do is I would add the property here. So Basil is the owner, so Basil will need to do that. Or what I can do is I can fork the part, which is basically I create my own copy of it. And then I will be able to add this property directly on the part itself. So whoever imports it will have access to that property. But going back to, wait. Here. So going back to this, so now let's say that I have this property, right? And then I can instruct in the parts instructions of for whoever uses this part, they can potentially just create a rule that I can actually import. So I can create this rule and make it available for other people. And what you can do is, so you can say, like, okay, I select my my part. So what I do is, you can actually code formulas in the rule itself. So for example, just a very quick one, I could do whatever, 1.5 over 10. And that will be the 0.5 millimeters, right? So it's not, I don't necessarily need to put one number. I can create a formula, but I can even explore this even further and say, okay, again, when you do this, you can click here for help. It's gonna tell you about all the different things that you can code. But basically, when I say equal this, I'm basically targeting this element, right? And I can say, okay, this element dot properties dot sliver, who got it? Remove. I forgot the name of the property. Where is this sliver remove? Yeah. So basically what I'm doing here is, if it has a sliver remove property, this is what I'm basically adding to this element. So if this element has a sliver remove property, I would use that value. Otherwise, I'm going to use whatever, 0.1. millimeters, right? So basically what this means is, just by adding this rule in my design, and I could even say, okay, this applies to all, component. Is it components? I forgot, okay. Hold on, I forgot the, footprint. Sorry. Okay. Again, apply to all the components. So if they have the property, I will put the I will basically create the solder mask that removes all the slivers. Or another, and basically what happens is if this object actually so if I change the property, so for example, let's say that the component is not exactly the same, right? It needs another value to be able to remove all the slivers, right? So if I change the property, it will be bigger. So what that means is that whoever created the component that was looking at the data sheet can put this value in their part. And then when you're using that part in your design, you automatically get the benefit from it. So in the end, people can start building in these type of properties, and then other people can use them in their designs depending on what they want, right? So for example, I can build a part, like, as Basti was saying, if you want to solder, I basically add two properties, right? One is solder by hand, and another property is solder by reflow oven. And then in my design, I added two different numbers, and then if someone uses my part and adds a rule in the design saying, okay, I want to use solder by hand or solder by reflow, I can, in my design, create a rule that it says solder by hand. I just copy and paste this, and then the path will change shape automatically to use that feature. Again, this is super powerful for collaborating and for building in flexibility into the parts, so that we minimize the cases where you need to create your own part. What you're basically going to do in the end is you're going to have someone else's part, and either fork it and create a better version, and then tell that whoever created the past, hey, like, I created a better version, you want to use it. And then parts get better and better, and they have built-in more complexity, so that we don't need to create parts many times and over. All right, so this is what I had for today. I know that there's a few things in the chat. Is there any questions?
I don't think there's any questions. I just put a link to the Slack community in case anybody wanted to join, keep the conversation going.
All right.
And then Brooks shared some documentation on all the expressions that you can create and use.
Mm-hmm. Yeah, and you can basically access all those. So either by Brooks's link, or so if you put equal whatever, you can click here, and it will take you to all the examples.
Oh snap! I forgot we did that. That's dope. Yeah. Boom.
So yeah, you can hear, or if you want to go about what the selector actually does, or the syntax, you can just click here. Right. So I don't know if anybody has any specific questions. Okay, let's chat. Yeah, we need groups of rules to turn on and off quickly. That would be useful. Yeah. Another thing to take note of.
Oh.
Yep, go for it.
Okay, this is a question for the class. Hi, Brooks, designer at Flux. This is pretty different, right? I joined late, so sorry, I didn't catch what we did at the beginning, but this is pretty different than DRC, right? Normally, you design things and then you like apply your DRC to be like, how bad or good did I do? This is like the exact opposite, right? Like this is your DRC from the beginning. Like I want it to work this way. Does that feel weird, or does that feel cool? Or how do your feelings feel about this?
Feels a lot like constraints in tools that I'd find like Fusion 360 or Inventor, where you basically add, you add constraints that two services are meant to be parallel. It feels a bit like that to me, which is a pretty neat feature.
Yeah, good point. Yeah, we called it rules. Maybe we should have called it constraints.
Yeah, I don't know. I don't know about the naming. That's just what it put me in mind of, and what, kind of what I was thinking about. One question that I had is, usually when I want trace widths, trace width isn't really what I want to specify. What I want to specify is a current carrying capacity
Yes.
of a trace. Is it possible to incorporate more information and have an expression that determines what the trace width would be based on like the thickness, based on some of the trace geometry? Like if I've got a 2 ounce, if I got 2 ounce copper versus ½ ounce copper, but I need, 1 amp, capacity, is it parameterized enough that we could pull that kind of information in?
This guy gets it. Yeah. But can we actually do that, Nico?
So we can do so. Eventually we will. So there's some stuff that you can actually do. So for example, so I showed you that you can create formulas, right? So one option, so it will not calculate the right width for you, but you can add the formula to calculate that depending on that, right? So for example, what I can do is, so if I add a property to the element, to say, for example, I want, so this dot element dot properties, I haven't created a property, but for example, dot resistance. And then, so if you know the resistance, what you can do is, okay, like I know the voltage. So I can say, okay, the width of the net will need to be whatever, 0.2 for each, like depending on the resistance, right? So you can do this slash like divided by 0.2. And it's going to fail because there's no resistance property. But if you define this, so for example, you can go to here or basically set the resistance in this resistor, right? So you got 14 ohms, and then you can use that to create the width that you want. So again, it will not calculate it for you. It doesn't know how much that width will need to be for the current that you need to carry, but you can create your own formula and put it there. And then if you change the resistance, it will change the width of the trace.
Yeah, that was really my question. Is it smart enough that I could actually put my formulas in? I mean, another application is if I'm I'm trying to construct a flex circuit that's a strain gauge, and I need a very tightly controlled, resistance that's based on some other parameter in the design. It feels like this is a path to parameterized design, right? Where exactly. I can impart the rules. I resort to doing this by, I've worked in Eagle a lot, and I export it and I write programs that basically, post process. But if I could build in some of those rules, that would be pretty cool.
Yeah, I mean, there's exactly, and that's exactly what this is for, right? So that you can build parameterized designs. And another option, for example, is, and this is something that happens in some of the designs. I'm going to try and see if this is a big project, and sometimes it fails. So basically, this is a microcontroller project that I built that basically has a bunch of submodules. So each submodule does something. For example, this is a reset submodule. This is a high frequency oscillator crystal. This is low frequency one. And then I have a USB-C or a USB-A input for the 5 volts, right? So in other tools, you cannot have the two things in the same design, right? Like you need to put one or the other, or you need to do some post-processing, right? Here, what I can do is I can add both of them. And then, for example, I can either other property that is called disable. For example, here, like I haven't implemented this fully, but for example, you can add a property that's called disable or enable false. And then what would that do is on the PCB, it will disable my USB-C module, right? And I will only be,
Look at
so
that.
I will only get the USB-A, right? See, you can do USB-A, or I can disable the rule and I get both. And same thing for the, for example, they say, okay, I don't need a reset on this version of the product. So you can grab the reset and then disable it. It takes some time because it's a big project, but see, boom, it disappeared. So you can build all these different projects in one, right? And start building more capacity. So this is the beauty of being able to code properties and edit and rules that edit the design, and they're not only sort of what I call like intentions. So you're not only declaring your intentions with the rules, you're actually impacting the design right away.
Does that answer your question? And do we have any other questions related to that maybe?
As we have already simulation, so in simulation, you know which part, which net will carry which current. So can we take this information from simulation and use it to understand how many copper do we need for this trace, and another trace? And I'm assuming that this is minimal trace because we can make it bigger if it's possible.
Yeah, I can chime in here. You can't do that right now, but that's definitely what we're working towards too, right? That you can also grab information from the simulator, like the current that flows somewhere or the peak current or whatever it is, right? To inform the width of a trace. That's a simple example for sure.
And you would also be able to plug that into the minimum trace width rule as opposed to the trace width rule. So then you would have your sort of like your limiter there. We talk a lot about this. I just want everyone to be super clear that like, we know some of this functionality isn't there yet, but we talk a lot about how you should not have to be specifying this stuff like hard coded. Like it should be based on the behavior of your parts. So that's really important to us, and we're working hard to bring that to you.
Actually, this idea about a group of the rules. It's actually what I'm asking, and Nico show the same thing that I'm thinking about. He shows a project with two different USB type connector, USB connectors. So this feature is available in Altium in latest version. It's called a version. You can create different version based on your schematic. So you just need to click, change the current version you're working with. So you can change the parts. You can change any part. So you can make some simplified or different microcontroller, because I even use it for some of my project because chip shortage. So I create a different microcontrollers, different version of same PCB with different microcontroller, and it's really handy. So basically, you have similar, really same design, same schematic, but different, something different. So you just click different version, and you once you click on this version, all components that not belong to this version will be deleted or changed. So why this is what I mean by make a group of rules. So this will be the version. So you don't need to change only USB type, but you can change something else. So this version 1, this version 2, and you just click, do one click, and you change everything.
You know, you're in a product demo for Flux and an Altium, right?
Yeah.
But so the thing about this is the cool thing about Flux is that we don't need to, most of these things we don't need to build for you, right? So we put the primitives there, and people, I mean, so for example, this is not a use case that was planned or oh, we put this so that you can do that.
Yes,
so
I understand, but I
whatever,
see this use case
whatever
for myself. Yeah.
And then basically our goal is to provide all these primitives so that people can build whatever features make sense for them. Let's say features.
Yes. Yeah. Okay. Thank you.
Does anyone else have any use cases that come to mind for something like constraints like this?
I think, go ahead.
Oh, sorry. I was just wondering if you couldn't make a simple lock rule and then apply the components you want to lock to it to that rule.
Sorry, I didn't answer the question, but it seems Brooks did. So you can
That's
go.
so cool. Yeah. Wait. Just say a little more. Say a little more about that. Why do you want that?
Well, I mean, like for my application, I design underwater robots. I have a lot of little parts that I would add in that I wouldn't want to make a rule that would end up changing all of my preset components. So if you make a lock rule that you just have it stipulated in there that it's set to these parameters, and add that to when he did the hashtag naming components, it would automatically add all of your components to that can't be changed.
That's sick. That's sick. Matthias, we talked about that. It's just so cool to hear that from a user.
I haven't got to use it yet.
Potential user. I think that makes a lot of sense, especially for like things that are mechanically constrained, like plugs and, you know, wherever it has to interface to other parts or peripherals. You might want to lock those and make sure you're not editing them with rules.
To give you a straight answer, Wally, is it? We don't have that yet, but Matthias and I have been talking a lot about that. I think it's really powerful, the things that we could do with that. So, but yeah, that's definitely on our minds.
Yeah, this is related to what Basil asked in so the first, well, one of the first questions. Exactly, like if I can add a lock rule to a specific component so that I cannot modify it by mistake if my selector is not exactly what I expected it to be.
Carrie, you also had a note.
Yeah, I had to find unmute real quick. I was going back to the same trace width comment. I really hate setting up rules around trace widths because it's just something that the tool should know. So current is one application of that, but also the differential impedance, single-ended impedance, differential impedance. It knows what impedance I want. I don't know why, and it knows my stack up. I don't know why I have to go and specify, you know, the trace width or the spacing for this. The tool knows all the things it needs to know in order to do that for me. And so whenever I click on a impedance controlled net, it should just do it for me and I shouldn't have to specify those things. I think that's something we've discussed a little bit, but just adding that to the pile for trace width definition automatically.
Amen. You should come work for us.
Okay, cool. Yeah, sounds good.
Travis, have we heard from you, man? What do you think about all this business? That's okay if you don't want to. There's a lot of us here. It's intimidating.
No, so there we go. I had to find the unmute button too. I thought my
Hey.
headset would unmute for me, but it didn't. So what do I think about all this? I'm only catching pieces and parts because I'll be honest, I'm jumping between meetings today. I tend to do that. So I plan on reviewing this and I can give you my opinion next time we talk. But today I've only caught pieces and parts, and I wouldn't want to give any info that is based off that.
That's okay. It's good to have you here, man. No worries.
Appreciate it.
Would it make sense to talk about, I mean, I love the rules discussion, and I love being inspired by like the different ways that we can leverage rules. And also wanted to highlight that we're doing another crash course starting next week. And I don't know if Nicolas, we want to speak a little bit about that for anybody who might be interested.
Yeah, so just for someone who's aware of what a crash course is, so basically, so we have we do an event that is basically 3 Fridays. So it starts next Friday and it goes for 3 Fridays, where we build something in Flux, and basically we go all the way from nothing to a product build at the end of the crash course. And what we're thinking about for the next crash course was to try and build something that is more of a, let's say, business use case or commercial use case. So we're thinking about something IoT. So either some sort of either a carrier board or a module with wireless connectivity, or some sort of hat or shield for Arduino or for Raspberry Pi. Another option was to build one of these, the Apple tags. There's the open source version of it. Build that one. So something that can actually be built in 3, or somewhat built in 3 sessions. So it's not too complex that will require us months. Of course, we will probably do some work beforehand. But yeah, so I don't know if anybody has any either ideas or specific things that they'd like to build. For example, or a theme. For example, one option was to create a BMS for the Raspberry Pi. So if someone is building sort of battery managed systems, that could resonate. So I don't know if anybody has any ideas or projects that they wanted to build that they're always pushing, postponing.
You mean you'll build my project for me, Nico?
Why not? It's a good one.
Deal of the century, guys. Get on this.
If it's a good one, if it's a bad one, he won't.
Yeah, if it is one. Well, it depends. Are you gonna make money out of it? So if you cut me in, then maybe.
I guess I gotta watch what I say sometimes. A lot of my work is very proprietary, high profile clients. But if you want to build a CAN repeater, I think I put that out there publicly on the Slack channel. Go for it. I'll be there for it, and at the end, I can utilize it. But I do have a question regarding rules and things like that, and maybe this was touched on, maybe not. I'm sorry if I missed it. And it was So say you've got, a circuitry, you want an inductor in, just say a pi filter, simple, that you're not certain on, the microhenries that you need for the inductor. Is there, is there a way to write a rule, set a rule to where it would determine that for you? You would put in essentially an inductor that has no value, and once you build up the circuit, given it has enough information, it could determine the microhenries that you require for your inductor, for example.
So yeah, there's no current way of doing exactly that. So it won't calculate based on, let's say, other parameters of other things automatically. You could do that yourselves. You will need to code that function, let's say, or that formula.
Okay.
So you won't do that for you yet. But yeah, the idea is that, so one of the cool things about having the simulator is that eventually we might be able to do all these type of things. Having the simulator in tool actually brings us all these benefits. It's not implemented, but it's one of the reasons why we have a simulator where we have it.
Yeah, can I ask a question about that? And I'm Jared. I'm a software engineer at Flux. I spent a lot of time thinking about the simulator and this kind of question. And I'm curious, like, how, if you have thoughts on how kind of generally useful something like that would be, like not pre-specifying values of resistors or inductors or whatever, and having the tool kind of help you figure out what the right values are. Is that a workflow that you would use that would feel good? Or is that,
It's a super common thing. I'll just chime in. It's a super common thing for me. I mean, for crystal oscillators and putting load capacitors on, there's just a formula. There's just a formula that you basically use. And what I end up having to do is put it in the notes, how I did my computation, and it's driven off of the parasitic capacitance of the traces connecting to the crystal. That's something that happens in virtually every design that has a crystal has that, which is virtually every design. And there are tons of places around the design where I just end up having to write the equations that I used, burden resistors, right? Just sort of over and over again. I feel like it's a feature that I would use a great deal.
Yeah.
And it would make the design much more self-documenting, which is something I'm always striving for in my, in my software. I do a lot of hardware and software design, but I'm always trying to make my software as self-describing as I possibly can. And it's something that always frustrates me about my CAD tools for doing, electrical engineering, for doing hardware design, is I end up having this disconnection between my, documenting what equation I had to use to come up with this part of my design. And it leads, it leads to think, what's the rule? If you have the same code in two places, it's wrong in at least one.
Yeah, right.
Yeah. It's something we spend a lot of attention to internally when we design these features, that we're trying to not make a drawing tool but an engineering tool, and allowing you to express why you want something a certain way, and not just draw a polygon or something. Right. And I think these formulas are a way to do that, right? Instead of like having some notes or some old Texas Instruments calculator there where you did the math. So the math is in the project. You can look it up, and it makes it easier to reason about it later yourself, or when you pass the project onto somebody else, or whatever it may.
Yeah, this was my hope when I first started hearing about the Flux tool. It was really my hope that there would be more of this sort of merging of what am I trying to do and why and how. Right? Because they're very separate in a lot of tools. I mean, they're getting better, debatably. They're adding some point features, but I was particularly interested in this rules discussion because I wanted to see if it was really heading in the CAD tool direction of constraints, derived constraints, driven constraints, things like that, which is very exciting to me.
Yeah, I totally agree. I think we're on the same page there with you. I think, I mean, we're very early with all of this, but I think we have a feature coming up where that's really going to be like really visible, which is like copper fills, where like, in traditional tools, you often end up drawing polygons for your copper fills manually, either at the end of the design process or whenever you do that, and then just, machine gunning them with vias. And what we're going to be shipping here in a couple of weeks is going to essentially do this automatically. Be like, hey, look, for this net, I want to fill on all layers, on top and bottom layer. And this is my machine gunning ratio I want. I want a via every centimeter, whatever it may. And then, it just does it for you. And like, if you want to move things around, it's going to get out of your way,
Jeremy, if there are other areas where you feel you need this type of functionality and we're falling short, if you're not already in our Slack community, we listen, we're in there. I would love it if you post those things. Then
Sure.
we can huddle around it, we can chat about it and figure out how to put that onto our backlog.
I got 30 years of
that.
bitching that I can turn in.
That's perfect.
I should turn into productive.
Bring it.
That's what we're about, man.
I spent a lot of time. I spent a lot of time thinking about how this, how this process could be better, because I work in so many tools and I get varying levels of this in different tools, and my circuit design and layout tools have just really seemed to have lagged a lot of other things. So if you guys want ideas, as they say, I'm absolutely full of it.
Jeremy, it's funny that you bring that up. I'm actually designing a interactive keyboard that does that. I'm designing a CAD keyboard that self-documents.
Nice.
Awesome.
Hey, I have a lot of interest in that. First articles and some things that would truly benefit from that. So I don't know if we could keep in touch, and however, I don't know if you're going to open source it, sell it, whatever you're going to do with it, but I'm extremely interested in that.
Okay. Yeah, just shoot me a message on this and I'll email you. If it works the way I think it's going to, and it's so far, all the prototyping has been pretty awesome, but it works with every single programming language in the world.
Yeah, documentation, production documents, like I said, first articles, you name it. Technical writing, unfortunately, becomes part of a role of mine, and that's my least favorite. So if there's a way to not just use software generated, which it usually comes out garbage and I can't turn that over to the customer, but if there's a way such as what you're talking about, yeah, that would make my job a lot more efficient.
Yeah, the way it works so far is if you add a part to a schematic, it adds the entire description that you put on this the part into another document.
I mean, that alone saves me from having to go out, copy, paste, even from, text sheets or what have you, and put in my own words, because I gotta watch copyright issues as well. So copy paste don't always work either. So yeah, I think that would help me a lot.
And I think looking through the way your the code works here on this program, I think I'll be able to make it interface with this to where you can put together something in the code. It'll auto document it into another program and build it in this.
Very cool. I put a link to our Slack community there if y'all want to join and we can connect.
Okay.
Also, I wanted to say to those that share the angst of Jeremy, 30 years of bottled frustrations, welcome to the revolution. We're doing it. Cool.
Yeah, I think
we're almost at time here, right? Oh, sorry, Nico.
No, the other part that I wanted to say is like, I very much agree on the making the design self-explanatory, and so that's why I added some of these examples of like not modifying a single component, a single pattern, a single via, and then you forgot why, and nobody knows why you did that, and try to move that. So the first step will be to make it clear, right? So you create a rule that says, okay, I'm exactly doing this for this reason, and this is how it applies, and then that will be the first part, and the following part will be that automatically using the simulator, it will create that rule or that formula for you. But I think they should just even having the possibility of explicitly saying what you want and not sort of hackily modifying things one at a time. That's already way better. And the things that I've been building, I go back after weeks, like, oh, like, yeah, I understand clearly why I did that. And that's for me has been great. Yeah, I mean, of course, the vision is to do that automatically, but like already the step in between is already much better.
Yeah, I've been through a lot of even my old code, but working with some other engineers, going through their code and asking them, you know, why is this here, and that they don't remember why, or their notes don't even, they can't even they're decipher from their notes as to why they did something. And just the other day, I took a picture and I sent it over to one of the engineers that I work with, and I said, "What's this for? That this breaks it. It doesn't make sense." And he had no explanation. So to have those rules so that you can look back on, I think is tremendous help. Also,
I'm lucky if I can remember what I did the last time I
Yeah,
touched
exactly.
the design, right? I mean, I always think of it as I need to document it. I need to document it for the next schmuck, and that guy's probably going to be me.
Me in the future. Yeah, like I
Right?
write
Yeah.
documentation for me.
That's right. Be kind to yourself is always the way that I think about it, because you've probably all had this experience where you're looking at some code and you're like, oh my God, who did this? This doesn't make any sense. And you go blame and you're like, oh, that was me.
That was me.
Yeah, and how it's even worse because you might not even notice that you did a change, right? The one via might be bigger than the other one.
Yep.
Like
have
you'll
the
never know
inverse.
that happened.
I have the inverse with Spotify playlists, and I'm like, oh, this is a good playlist. Who made that? Oh, that was me.
I love when that happens. I get
follow
shit
this
all the
guy.
time.
You start.
I like
following
all the
yourself.
songs on this. What great taste.
That's all just Katy Perry, though.
It's,
On the
well,
real.
I was man of simple taste,
Matthias, you were the #1 listener for who was it? Ariana Grande in the world?
Oh, no, Miley, no, not the one, but I was like in the top 0.1% of Miley
1%.
Cyrus listeners.
That's right.
Last
Fun
year, I
facts
think,
about
or
Matthias.
before. Mhm.
Oh my
I
god.
don't even know how, but yeah.
Whatever helps the code flow. Right?
That's right. It's a party in the
My
USA.
secret.
That's what makes the code flow,
All right, you guys. I think
I
we're
have
at
one
time,
quick
right?
question
Oh,
about
yeah, go for it. Go for it.
about the program here.
Wally, look at your setup. Oh my God. This is the coolest video stream. Can I subscribe to your Twitch? Everybody look at this.
I just finished my bachelor's in electrical engineering back in November, so I had to switch the whole remote setting. So I built my home office to support that. I made all
love your
that.
battle
I love it.
station.
Yeah, this is my pride and joy. One of my pride and joys.
Oh my God. So sorry to interrupt you, Wally. What was your question? I'm in shock.
I see up there that you can switch between the schematic code and PCB view. Can you
Yes,
put
sir.
those on different monitors at the same time?
Yeah, you
Hell
can open
yes.
Oh,
two
awesome.
different instances of this, and then have one on each, and they sync real time. So yeah, it's basically having
Right,
one.
can
on
you
each
have them on
monitor.
different devices at the same time?
Yeah.
Yep.
Hell yeah. This is all live collaborative in the browser. So that means whether you have multiple monitors or tabs or other contributors have multiple are joining in, it's all live and synced.
Okay.
So you could have 3 windows and one Windows schematic, the other Windows code, the other Windows PCB. It's all the same project. It's all live synced between each other. Pretty cool.
That is great.
Yeah, it's especially nice if you work on a project and then the parts that you're using at the same time. You can have just multiple windows open and see it all at the same time. And you make a change here on the right and you have it on the left, right? It's really cool.
Yeah, I'd say being able to run schematic and layout on separate monitors with forward and back annotation, that would be a deal breaker for me these days. I keep them on separate monitors and I always go back and forth. So I remember the days before I had that and I refused to go back.
After I set up like this, I've got 4 monitors set up on this one thing. I could never go back to just having it on one screen.
Yeah, I feel like we're only seeing half of what Wally's setup really is. I feel like you have like a wall of monitors right now, like Matrix style.
Well, I got a 55-inch TV on the wall and I spaced it out perfectly between my desk to where the TV sits exactly on top of my monitor.
Nice.
If you don't post your battle station in our Slack, I'm gonna be really mad.
Don't. I wouldn't cry seeing my setup now.
Well,
I'm gonna get depressed.
This is the little one. I'm building a bigger one. I just closed in my carport, turned half of it into a workshop and the other half into electronics lab.
Congratulations, we're featuring
Nice.
you're featuring you on our website. It's so cool.
So believe it or not, I actually built all that for $100.
That's incredible.
So going to the multiple screens and multiple devices, multiple users being collaborative, is there a point where it begins to cause lag in your project if you've got, X amount of individuals or tabs or screens or whatever and what have you in the same project?
Yeah,
You don't have performance issues.
I mean, so yeah, it's a good question. We had people in the past here who were like college professors who use it with like 40, 50 students, and that definitely is a problem. I forgot the number, but I think, up to like 10, 12 definitely works well. I think what makes a difference is whether the other users are also editing with you at the same time, or if they're just only viewing. You can certainly have more viewers than you can have right now active collaborators, but yeah, the actual boundaries depends a little bit, on the size of the project, how fast the computers are involved, but it's definitely something we're working on to make a lot better, and we're working really hard on. Yeah.
Okay, thank you.
By the way, I just made a Battle Stations channel in our Slack. So we can all share.
Fuck yes.
Y'all gonna make me turn all the lights back on, huh?
So I don't use mine much for battle stations, but you guys can't see it. I got a projector that I use over here. Usually I've just got some music videos or something playing on it, but it does come in play to throw up a schematic on that while I'm sitting here trying to build it.
Jesus.
Pixar didn't happen, Travis.
What's that?
Pixar, it didn't happen.
I can send you pictures, as a matter of fact.
Please.
I will post it in the channel.
Yes.
Hell yes.
Cool. Should we wrap up?
Yep.
Cool.
Travis,
Thanks,
I'll email in about 5 minutes.
All right, I greatly appreciate it, man.
All right.
Thanks, everyone.
Right, everybody. Have a nice rest of the day and weekend.
Have a good one.
Again.
Thanks, y'all.
Likewise, happy Friday.
Everyone.
Bye.
Cheers. Bye.